Hello guys, let's wait for everyone to join. Let's wait for everyone to join the live, then we will start. So we are going to discuss about the problem which is rainwater trapping. Okay, trapping rainwater, and it is a very important problem. I just thought so that while interacting with you all, we should also do some learnings and some things. So that is why I just decided to go some one or two problems live solving, and which will be basically important problems too. So that is what we thought. So just came up with that idea कि ऐसा करते हैं, and so we will be just stuck with the same problem, which is the trapping rainwater. उसी को पूरा last तक discuss करेंगे. We'll discuss all the different approaches. Till then, just tell me, guys, if my audio is clearly audible. If I'm clearly audible to you all, if the voice is clearly audible, so that we can move forward. You can also like the video to tell me this thing that yeah, I am audible clearly. Okay, great. So yeah, so now let's move towards the problem before any delay. Let's solve the problem only, which is right. So I hope that now my screen is visible to you all. Okay, and good evening, guys. Good evening, everyone. So the problem is this. I have written the code. Let me first erase the code. Okay, whatever I have written. So we will discuss it from start. Okay, yeah, that is it. Great, guys. So the problem is something like this. You can see here, which is trapping rainwater. Okay, you are basically given with non-negative integers. Okay, and you are basically given with a bar graph. Okay, and in that particular bar graph, you have to find that how much water is trapped inside it. Okay, so if you will just see this example, this particular code, this particular figure, you can see that. Or let me also copy this figure in the whiteboard so that you can get the understanding of it. Okay, so this is what you can see. Okay, so this is a diagram, and here we have a bar graph. Okay, you have to tell that how much water is basically trapped in that particular bar graph between them. Okay, uh, and the height of each bar is given to you. So if I will just write the indexes and the height of it, so this is the indexing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the size of the height of each bar is something like 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. Okay. This is the height of each bar, and this is the index of each bar. Just write a +1 if this problem is clear to you all. That's what we are doing here. Is this clear to everyone? How we are, what the problem is, what we have to find. We have to find the water filled between these bars. That is what we have to find. Okay. Just give a +1 if this thing is clear to everyone. And what the problem is, what exactly the problem is asking to us. This is a very important problem which is asked in many of the companies, many of other or top product companies too. Great, guys, great. Also, don't forget to just hit the like button and also share this video with your friends so that others can also join this particular live. Okay, great. So now what we will do, there are different ways for solving this particular problem. If you will focus on it, why the water will be stored in a particular block? एक block पे पानी कब store होगा? There is a condition when the water will be stored in a particular block. एक block पे पानी तभी store होगा when there is a block which is greater than it in the left and in the right also. जब उस block से बड़ा एक block उसके left में होगा और उस block से बड़ा एक block उससे right में होगा. अब देखो एक चीज, ठीक है, अब अगर हम लोग इस वाले को फोकस करें, इस वाले ब्लॉक को, सो यू विल सी वन थिंग, इस ब्लॉक में पानी क्यों स्टोर हो रहा है? बिकॉज इसके लेफ्ट में एक ब्लॉक है जिसकी हाइट इससे ज्यादा है, इसके राइट में भी एक ब्लॉक है जिसकी हाइट इससे ज्यादा है. दैट इज वाई वहां पर पानी स्टोर हो रहा है. ओके, सिमिलरली इस ब्लॉक में पानी क्यों नहीं स्टोर हो रहा? इस ब्लॉक में पानी क्यों नहीं स्टोर हो रहा है? बिकॉज इसके लेफ्ट में तो एक है ब्लॉक, यू कैन सी दिस वन, जिसकी हाइट इससे ज्यादा है, बट इसके राइट में कोई भी ऐसा बार नहीं है, कोई भी ऐसा ब्लॉक नहीं है जिसकी हाइट इससे ज्यादा हो. दैट इज वाई इस ब्लॉक के ऊपर, इस बार के ऊपर पानी स्टोर नहीं हो रहा है. ओके, दिस इज द थिंग दैट वी हैव टू ऑब्जर्व. दिस इज द थिंग दैट वी हैव टू ऑब्जर्व. ओके, ये चीज समझ में आई, ये लॉजिक, पर्टिकुलर लॉजिक समझ में आया कैसे कर रहे हैं. ठीक, अब आगे बढ़ते हैं कि हम लोग ये चीज फाइंड कैसे करें. हाउ वी विल फाइंड दैट, how we will find that in this particular case, how we can find that is there a larger graph in the right or in the left. Okay, so this is the thing which we have to basically find. So okay, so now let's continue with the code part. And okay, yeah, I'm telling English only, fine. So this is what we will do. Okay, now for finding that from each index, is there a larger block present in the left or not, or if there is a larger greater block present in the right or not, there is a brute force approach. Brute force approach is that we will iterate for each and every index. So we will iterate for this, for this, for this. Similarly, for all the indices, we will iterate. Okay, and let's say that we are currently at this particular index. We are currently at this particular index. So for this index, if we have to check that if there is any block greater to it, height greater to it in the left, and or height greater to it in the right, what we have to do is we have to basically iterate to the left side first and then right side. So पहले तो आपको पूरे array को iterate करना है. Then for each index, first you have to iterate the complete array. Then for each index, you have to iterate the left and the right. So just tell me, what will be the time complexity of this particular approach? What will be the time complexity? The first thing, we are iterating the complete array. Then for each index, we are iterating to the left and to the right also. So what will be the time complexity? Tell me this thing. If you don't know, just tell me that I don't know or something like that. That I will discuss, okay? N cube, exactly. Great code with that. It will be n cube. It will be order of n cube. Fine. Why? Because the first for loop will be to iterate from 0 to n. Okay. The second for loop, let's say currently we're at ith index. The second for loop will from 0 to I, and which will be from left side, and other will be from I to n. That to iterate for right. No, not this. It's not n square. It's n cube. It will be n cube. Okay. But this will be the brute force approach. This is going to be the brute force approach. Okay. This is not the most efficient approach. The most efficient approaches are something different. What we will do, we can use the concept of prefix and suffix array also. There is a concept of prefix array and suffix array. We can also use that concept. Let's see how. Let's see how that concept can be used. Okay? So you can see here one thing. You can see here one thing, that what we want. We want that from an index, what is the maximum length bar in the left and what is the maximum length bar in the right. So first of all, we will iterate from the left side. Okay. And while this iteration, what we will do, we will store the maximum height till now. So till index 0, no, I just want reply from you guys. Okay. Till index 0, what is the maximum height? So till this index, till index 0, is index tech, maximum height kya hogi? What will be the maximum height till this index? It will be 0 only. It will be 0 only. Now, for next index, the maximum height is 1. Okay, great. For next index, maximum height is again 1 only. To the क्या होगी? 1 होगी ना? So till 2, अब आपसे कोई पूछे कि यहाँ से यहाँ तक सबसे maximum height का बार कौन सा है? You will say height of 1. Okay. Similarly, till index 3, height will be 2. 2, 2, 2. From here it will be 3. Then 3, 3, 3, 3. This is what you can easily find. This is what you can easily find. This particular approach. Just using the prefix array. Just by implementing the prefix array method. Just guys, just hit the like button if you are getting the things so that I can know. Okay. Great. Now, so this is clear now that how we are finding the for each index, how we are finding what is the maximum length which we have in the left of it. Okay. Similarly, what we will find for next case, which is from the right side. From the right side also we will find the same thing. So now we will check from the right side that what is the maximum length of a particular bar. So from here it will be 1, then 2, then 2, then 2. Here we have 3. Then rest of will be 3, 3, 3 only. It is saying that, for example, we are checking this index. It is saying that from here to the end, we have a maximum size bar of 3. You can say it is 3 only. Okay, it is 3 only. This is what you have to do. This is the most basic thing that you have to do. Okay, great guys. Great. This is okay. If this thing is clear, then most of the thing will be clear to you. Okay. Just tell me if this is clear to you. Okay. Great. Okay. Now what we will do, you can observe one more thing that we are going to discuss in this particular problem, that let's say that this is the index we are considering. For this index, if we have to find that what is the maximum size, maximum height bar in the left, so that will be 2. That will be 2. And which is the maximum height bar in the right, that will be 3. So means इस इंडेक्स के लेफ्ट में एक बार है, इसकी हाइट 2 है, इस इंडेक्स के राइट में एक बार है, इसकी हाइट 3 है, मैक्सिमम हाइट के बार. That is what we know. Okay. Now, what will be the amount of water stored in this? Can anyone tell me? What will be the, means till what height the water will be stored for a particular index? जो कि बता सकता है एक पर्टिकुलर इंडेक्स में कितनी हाइट तक वाटर स्टोर होगा? Till what height water will be stored in a particular index? If we know that what is the maximum length in the left and what is the maximum length bar in the right? 2. It will be 2, but how? We can find it using exactly minimum of these two, actually code with depth, the minimum of these two. So for this index, if I have to find that till how much height the water will be stored, it will be the minimum height of its left largest and its right largest. So minimum of this 2 and 3 will be 2 only. And you can see that till 2, the water is filled in this particular index. Till 2, the water is filled. Okay. Now, what we will do here, that also this bar also has a height of 1. Means with the height of 1, the water was not there, the bar was there. So we will subtract this 1 from here and the answer will be 1. And you can see that 1 is the amount of water which is stored in this particular bar. 1 is the amount of water which is stored in this particular bar. This is how we will find. Okay, this is how we will find this particular thing. Similarly, for all the other, the basic formula will be that the minimum of left eye and right eye minus ARR of I. This will be the amount of water which will be stored for a particular bar, for each bar. And this is what we will do for each and every index from 0 to n minus 1. Is it clear? So can you tell me that what will be the time complexity and space complexity for this approach? What will be the time complexity and space complexity for this approach? Just tell me this thing quickly. The space and time complexity for this given approach. Tell me this thing. Order of n and order of 2n. Exactly. Great. So the time complexity will be just order of n because we are just iterating to the array. Okay. So it will be order of n. And time complexity will also be considered order of n only because order of n, order of 2n will be considered to be same. Okay. It is considered to be same. And we can also write it as order of 2n. It's fine. Okay. So this will be the time complexity and space complexity for the given approach. Now, can we solve this problem with constant space? Can we? Okay. So the implementation which I have written is basically for the constant space only. Let me share you. I have solved all the three. I have solved with all the three approaches. But the most amazing approach is this one, which is the constant approach solution. This is the constant approach solution. And we will be discussing this solution only. Okay, so let me copy the code. Okay. Yeah. This is going to be the constant space solution. Okay. Let's see how we will do this. Let's see how we will solve this particular problem with constant space. So before that, let me just remove everything, whatever I've written. So there are some 8 viewers now, but only 2 of them are responding. I think that all of you should respond now. Okay. Now, what we will do for this particular approach, this is a 2 pointers approach. This is a 2 pointers approach. We will have 2 different pointers. The logic will be exactly same. That we have to find the left max and right max. Means the length of a bar which is in the left, the maximum bar in the left, and the maximum bar in the right. Okay. For that, we will have two pointers. So the first pointer will be, let's say, left pointer. So let me not write a data type. Let me just write left, which will be equal to 0, and the right pointer, which will be equal to n minus 1. So in this case, if I will again write the indexing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So for this, what will happen is that you can see here that n will be 12. So the value of right will be 11 only. Okay, the last index. We will have 2 more variables, which is the left max. Let me write it on the top, left max and right max. It will be left max, which will be 0, and right max, which will be 0. Okay. So left max and right max will be the 2 variables that will obviously store, as the name suggests, the left maximum value and the right maximum value. That will be stored by this left max and right max variable. Okay. Now guys, what we will do, we will have our left here, as I told you, and a right here. Okay. Now, what we will do, let me combine them. Okay. So there will be some approach which we will follow. The first thing is that if the value at ARR left will be less than the value at ARR of right. यार क्या हुआ? डिस्कनेक्ट हो गया क्या? So my AirPods are getting battery. I think. Okay. Thanks. Let me charge one of it. Till then, the second will work. Okay. So yeah. So this is the thing that we have. Okay. Great. Great. So if our left is less than right, the first condition is that if our left is less than right, in that case, what we'll do? In that case, we'll update our left pointer. Okay. And if our right is less than left, in that case, we'll update a right pointer. So you can see here in the code what I have written. Let me zoom in. These are the things which we have in. And here we have an answer also, where we will store the answer, obviously. We will store the answer. So let's take an answer here also, which is initially 0. Okay. Now you can see the approach, the complete code here. Okay. The code is something like that. If our left value is less than equal to a right value, if our left value is less than equal to our right value. Okay, maybe this is not so clear. Now let me do it like this. Okay, I hope this will be now more clear to you. Okay, am I audible now? Just please confirm if I am clearly audible now. Am I audible? Okay, 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 great, great. So yeah, it was just my airports were got discharged. Okay, yeah. So this is what we are doing here. Fine. So the next thing is that we will do. You can see the first case is that if our left height is less than equal to the right height, if our left is less than equal to the right, in that case what we are doing? In that case what we do? कि अगर हमारा जो लेफ्ट है वो राइट से छोटा है, ओके, उस केस में देखो क्या करेंगे. उस केस में भी दो कंडीशंस बनेंगी. ठीक है. तो पहली कंडीशन हुई, द फर्स्ट कंडीशन इज दैट आवर लेफ्ट, द वैल्यू एट लेफ्ट is less than value of right. You can see that condition is fulfilled. The value of left is basically 0. Let me write the values again. So you can see that the value at left is less than the value of at right. Value at left is less than the value at right. Okay, so this condition is fulfilled. Now the next is that obviously we have a left maximum. We have a left maximum. So whenever we get a left value which is greater than it, so obviously we have to update it. ऑब्वियस दिस इज अ केस कि अगर हमारी कोई भी लेफ्ट वैल्यू ऐसी आती है जो लेफ्ट मैक्सिमम से बड़ी होती है, so we have to update the left maximum because we want the left maximum to be maximum among all the left values. Okay, so currently you can see that if our height left is greater than equal to left maximum, then we will update it, and that is the case. So our left is basically 0 and our left maximum is also 0. We will do nothing, we will just move forward. So in that case we will just move forward with left plus plus. Okay, we will just move forward. So this left will be now at 1, so that will be now at 1. This is now at 1. Okay, now what we will do is that again we will check for the condition that if our height left is less than equal to height right, again that is the case. You can see our left is 1, our height left is 1, and our height right is also 1. They are equal. So again this condition is true because it is less than equal to. Now again you can see that it will first check that if our height left is greater than equal to left max. So yeah, it is. Our height left is greater than equal to left max. Is greater than left max because our height is 1, our height is 1, and left max is 0. We'll update the left max by 1. So thought difficult, I know this is quite complex, but it will take some time to explain. Na? It will take some time to explain. Okay, it will be 1. Again, we'll update the value of our left pointer. Again, left pointer will be updated. Now you can see that our left is 0, means the value of left. The value of ARR left is 0, and the value of ARR right is 1 again. Again, this condition is true. The condition is that left is less than height right. The other condition is false, means left is not greater than or equal to left max because the ARR left is 0 and left max is 1. That means we will go to the else part. So else part will run when the value of left is less than left max, and you can see the value of left is less than left max actually. Now in this case, that is the case you have to observe. You can see in this case water is storing in this index. Water is stored in this index. And also you can see one more thing, that we have also clarified that particular condition. The condition was that the element which was in the left was also greater than it. इसके जो left का element था means left max was also greater than the array left, and the value of right was also greater than left. So right भी greater है, left max भी उससे बड़ा है. इसका मतलब यहाँ पे पानी store हो सकता है. That means water can be stored here. So if water can be stored here, how much water? That water will basically be left max minus ARR of left. This much of water will be stored. This much of water will be stored. You can see left max is 1, ARR left is 0. So 1 is the amount of water which is stored. And you can see 1 amount of water is stored here. Is this clear or not? I know this is quite complex, but just try to understand in a good way. You can also watch the recording and try to solve this by your own. Then you will get in a good way. Okay. And again, after incrementing the answer by 1, because left max minus left was 1, so we will increment the answer and we will move forward. Now you can see that first condition is not true. The first condition was that our height left should be less than height right. But here you can see our height right is less than height. It is, the condition is false. So we will move towards the second else part. That if left is greater than right, so this else part will work. In else part, the same algorithm is written but for the right. Now we will check for the right and the right max. You can see that the value of right is greater than the right max. So we will do nothing. We will just update the value of our right max. Because right is 1, right max is 0, we will update its value. And then we will update the value of our right pointer. Again, you will see that the left value and right value are equal. So again, this first condition will be true. Okay, this first condition will be true. But again, the value of left is greater than the value of left max. Left max is 1 and left is 2. We will update the value of left max to 2 and we will update the value of left 2. Now you can see that left is less than right. Left is 1 and right is 2. So left is less than right. So this particular condition will run, and in this condition also you can see that right is also equal to, so right is 2 and right max is 1. So means right is less than right max. So right max will be updated. So this will be updated to 2 and right max pointer will be right will be updated. Now you can see again right and left are equal. Right and left are equal. So this condition will be run and again the answer will be incremented with left minus right left max minus left max is 2, left is 1, means 1 is the amount of water which will be exactly still first consider, so which will be added, so 1 will be added. Okay, and we will update the value of left. Now you can see left is less than right, so the second condition will work. Second condition will work, and also right is less than right max. Also right is less than right max. So this condition will run, and we will add right max minus ARR of right in the answer, which is right max is 2, ARR right is 1, which is 1. That means one amount of water is stored here, and we will add 1. Okay, so here I think that second condition is not true. The first condition is also true. Means ये वाली चीज आएगी ना, ये तो मैं थोड़ा सा गलत कर दिया. First condition is true होगी. So first condition true होगी ना. Yeah, sorry for that. ये यहाँ पर ही रहेगा. Left clear करेंगे. So for left it will be left max minus left, which is left max is 2, left is 0, so 2 will be added. So plus 2 will be there, and then left will be incremented. Now in this case you can see that again the left pointer is less than the right pointer. So the left pointer is less than the right pointer. So again the same thing will happen, and also the left is less than the left max. So left max minus left means 1 will be added to the answer. That means one amount of water will be stored here. One amount of water is stored here. And again we will update the value of our left pointer. In this case what will happen? In this case it will be that our left is greater than right. Our left is greater than right. So we will update the right pointer. Again our left is greater than right. So again, but here you can see also our right is less than our right max. So we will add the value of right max minus ARR of right in the answer. That will be 2 minus 1. That means 1 is the amount of water here and 1 will be added here. And again what we will do, we will just update the value of our right pointer. We will just update the value of our right pointer. Again you can see left and right is left is greater than right. Again right will be incremented, and now both the point meet at a single point. We have to run until left is less than right, but now they both are equal. So now here our condition will be stopped. Here our loop will stop, and you can see that the sum we are getting here is answer we are getting here is basically 1 plus 1 plus 2 plus 1 plus 1 6, and you can see here also the test case also the answer is 6. Okay, the answer is 6 only. So this is the most optimized way. If we talk about the time complexity and space complexity for this approach, just tell me guys the time and space complexity for this approach, what we have written. Tell me quickly in the chat box. Just quickly the time complexity and space complexity for this approach. So the time complexity will be just O of n. O of n. Because we are just great Nitish and Dev. Great. So because that we are just iterating with 2 pointers. Time complexity will be order of n and space complexity will be order of 1. Because we have not used any extra space. And that will be the most optimized solution. This will be the most optimized solution for this particular problem. This problem has been asked in Google, Amazon, Microsoft, Flipkart, many such companies. Okay, so this is a very important problem. I will just recommend you guys. So again, solve this problem by your own. I will share the link in the chat box. Let me just share the link in the chat box. You should again solve this problem by your own. Okay, and this is a very amazing, very important problem for you guys. Okay, so this is the problem that we have discussed. I hope that you have got whatever we have discussed. Is it clear to everyone? Tell me. Is it clear to everyone now? It's great. Great, guys. So now we have discussed the problem, and it's, I think, approx 35 minutes. So the problem was really good. So it takes some time to solve and to discuss the problem. Let me just check if my, yeah, that monotonic stack can also be implemented, that I know, that the monotonic stack can also be implemented. Okay, I think that they are charged now. Yeah. So just tell me if I'm not audible now. Just quote with Dave that monotonic stack approach can also be discussed, but that also takes extra space now. So, but this is the most optimized way. It is not taking any extra space or anything. It is just the most optimized way. So, low audio. Okay, is it fine now? Yeah, I was saying that surely we can use the monotonic stack also, but that will also take extra space, no? So, but this is the most optimized way. How we are basically using the uh, without any space, content space, constant space, and with the order of n time complexity. Okay, so that was the problem. I hope that you all have really liked it. Now, just if you have any doubt, let's have a doubt session, ask me anything session for the last 5 minutes, and then we will conclude this stream. Okay, just for the last 5 minutes, we will have a doubt session type of thing. Okay, and then we will conclude the session. Okay, guys. So I think that now we should conclude the live. And before leaving it, please hit the like button so that I can know how many of you have joined. And if this live is helpful for you, just comment helpful just after the live. Okay, okay, sure. Okay. So you are asking for monotonic stack. Sure, I will try code with that. I will try to make a video on that. Okay, so that I will surely try to make a video on concept of monotonic stack. Okay, no problem. Fine, guys. Okay then. Thank you for watching. I hope that this is a very basic problem of two pointers, and this is a very famous problem actually. So the prefix sum and suffix array approach is something which can be thinkable, which is approachable. But yeah, I can say that the third approach, which was two pointers, is quite complex. Maybe one cannot get that approach in the one flow. Maybe you have to solve the solution. It's okay. Thing is that if you have understand that approach, it's fine, and just don't forget it, so that if you will solve the similar problem next time, you should know, remember that approach. That is very important. Okay, it's fine, guys. So okay, guys, then it's okay from my side. Let's meet in the next video. Till then, bye bye, take care, thank you very much, bye bye.